In this video, I'll show you how to solve the ALEKS problem called Understanding the Definitions of Ionization Energy and Electron Affinity. Because this problem is really big, doesn't fit on the screen, I've taken this data table here, cut it, and rearranged things a little bit. So here's a rearranged version of the problem. This is the data table that was up at the top of the screen. This way it all fits on one screen. This problem is a lot easier than it looks. ALEKS has given a lot of unnecessary information in this problem, which just makes it kind of distracting. So let's start by going through and just cutting all that unnecessary info. So first of all, ALEKS implies that you're going to need to use the data tab to solve this problem. I did not find that necessary. I don't think you will either. Also, in this table of data that ALEKS provides, there's a lot of information you're not going to need to use. The atomic mass is not necessary. Electronegativity is not necessary, and the heat of fusion is not necessary either. This problem is just about electron affinity and ionization energy. Let's define both of those really quick just so that you can work on this problem. The electron affinity is a measure of how much an atom wants to pick up an electron. And that can be described with the chemical equation atom plus electron. It's an electron affinity. How much does that atom want that electron? This turns the atom into an anion because it has picked up an extra electron. An anion is a negatively charged ion. And then the ionization energy is just the opposite process. So this is an atom being ionized or losing an electron, which causes the atom to turn into a cation, which is a positively charged ion. This is a difficult process for an atom, ripping an electron away from it. So this is a process that requires energy. We've got to give the atom energy in order to do that, or the term that ALEKS is using here is that it absorbs energy. Requires and absorbs energy. The electron affinity is one that releases energy. Okay, so these two definitions here, with these numbers, all you need to be able to solve the problem. So ALEKS is going to give you two equations, chemical equations. This is my first one right here. And what you're going to do is take this equation that was provided to you, and you are going to match it up with either the ionization or the electron affinity equation or the ionization equation. So you're just looking for a match. I have an atom on the left-hand side, turning into a cation and an electron. That's this process right here. Atom turning into a cation and an electron. This is the ionization energy. This is a process that absorbs energy. So there's the answer to the first question. Is it possible to calculate how much energy? Yes. The answer to this question and the similar question down here is always yes. You're always going to be able to know what the energy is because ALEKS has provided you with those numbers. How much energy is involved in this process? Well, we said this was the ionization energy, and so there it is. That's how much energy is involved, 1008.4. Because of the way ALEKS has worded this particular question, it's just asking to enter the amount of energy, the magnitude of energy. It doesn't want you to say if it's a positive or negative energy. It just wants you to enter the amount. This number is always going to be a positive value of energy, no matter what. Okay, so let's do it again. Here is equation number 2. We're basically going to do the exact same thing, but with equation number 2. This one's a little bit trickier. So here I have an anion that is turning into an atom plus an electron. And you can see that that is not a perfect match for either of these equations. Anion on the left, I don't have that on either. Now you are, for some of these problems, you are going to get an equation, like I have here, that is not a perfect match with either of these, but instead it's the reverse of one of these. So this equation here, because it's not a perfect match for either the electron affinity or the ionization energy, I'm going to start looking at the possibility that it's a reverse. So I'm going to look for an equation that has an atom plus electron, not on the right-hand side, but on the left-hand side. There it is right there. Atom plus electron turning into an anion right there. So this reaction is the opposite or the reverse of the electron affinity. Now, if you have an equation that is the reverse of the electron affinity, the energy is going to be the opposite of what it would be for the normal electron affinity. So instead of releasing energy, it is going to be absorbing energy, but that does not mean that you cannot calculate how much energy there is. It's always going to be the same. This answer is always going to be yes. And the number we're looking for, because this is the reverse of the electron affinity, that value is the same as the value of the electron affinity, it would have a different sign, but ALEKS is not asking us about signs. This number, we want to express it always as a positive number.